Hello, everyone. My name is Katelyn May, and I'm currently a PhD student in information science at University of Washington. This talk presents our work that investigate bias against 93 stigmatized groups in mass language models and downstream sentiment classification tasks. Let's start with the motivation behind this research. There has been great efforts in natural language processing research that aim to identify social biases encoded in language models. Most prior work focuses on biases related to gender, race, and religion. However, there has been little attention paid to social stigmas, which can be also considered a key element of social bias. Socially stigmatized conditions are often related to disease, disabilities, mental illness, socioeconomic status, and etc. Considering all the stigmatized conditions, social stigmas affect a substantial amount of people. In the United States, recent studies show that there are around 60% of the population experiencing a chronic disease. Around 22% of the population experience one of the mental illnesses in 2021. And around 26% of adults experience a disability. Numerous studies have shown that social stigmas prevent individuals from social activities and access to education, healthcare, and career opportunities, negatively influencing their psychological well-being and life outcomes. As language models capture other social bias, they may also learn bias against socially stigmatized groups. Therefore, in this work, we conducted the bias evaluation study that focuses on a comprehensive list of social stigmas in the United States. With this work, we extend current focus of bias evaluation in natural language processing research. We also provide a new approach for bias evaluation of social stigmas. At the meantime, we also examine bias correlation between mass language models and a downstream task. The list of social stigmas is adopted from a psychology study, Perchankis et al. Their study identifies the current social stigmas in the United States and evaluates individuals' perception of social distance from these stigmatized groups. The 93 stigmatized groups in this study covers multiple categories, including ethnicity, sexuality, profession, physical traits, education, mental illness, religion, drug use, socioeconomic status, disease, and other conditions. To investigate if there is bias against this group, we also identified 29 non-stigmatized groups based on each category. We ran our experiments with 6 mass language models and 4 of their downstream sentiment classifiers. To investigate bias in mass language models, we used a prompting approach and curated our prompts based on the social distance scale, which is commonly used psychology scale that measures social rejection to stigmatized groups. The social distance scale asks 7 questions related to participants' willingness to interact with stigmatized individuals in different social interactions. The more unwillingness indicated in participants' answers suggests a greater social rejection of individuals with stigmatized conditions. One of the questions in the scale asks, how would you feel about renting a room in your home to someone who has certain condition? We then converted each of the 7 questions into 4 prompt templates to prompt the mass language models. For reference, we also have a list of all the 7 questions from the social distance scale listed here. So in each prompt, we have a prompt template filled with either a stigmatized or non-stigmatized condition. The mass language models are expected to predict on a mass token. Then we annotated each predicted word in terms of positive, negative, neutral, or relevant based on the context. And then we filter out the words that are irrelevant and calculated the probability of negative words, positive words, and neutral words. In this case, we have 7 prompts that derive from the 7 questions of the social distance scale for each condition. And each prompt with a condition has a probability of negative words that were aggregated based on our annotations. Then we aggregated all the probability of the negative words such that we have a probability of negative attitude for each condition. Comparing the overall results for stigmatized and non-stigmatized conditions, we observed that all 6 mass language models tend to predict more negative words when prompts include stigmatized conditions. And this tendency is consistent across all the 4 prompt templates that we use. Look at the results for each condition. We found that mass language models are more likely to predict negative words in prompts that include stigmatized conditions, specifically related to physical traits, mental illness, drug use, disease, and disability. To evaluate bias in the downstream sentiment classification task, we curated prompts for each condition with these 2 prompt templates. Similarly, for each prompt that includes a condition, sentiment classifier predicts the sentiment of the sentence that include the condition. Then we aggregated all the classifications from all the sentiment classifiers for each condition, and then analyzed the difference between stigmatized groups and non-stigmatized groups. This chart shows the results of all the sentiment classifications for both groups. If we look at the red bars, we can see that the proportion of negative classification is much higher for prompts that include stigmatized conditions. These results indicate that downstream sentiment classifiers are biased against stigmatized groups. We also observed that these biases are consistent with the bias observed in mass language models. And we did that by measuring the correlation between the proportion of negative classification and the overall probability of negative attitude for each condition. We provide detailed classification results for each condition in our paper if anyone is interested. So in summary, the findings of our experiments demonstrate that current pre-trained large mass language models and the downstream sentiment classifiers are biased against stigmatized conditions in the current US society. We encourage future work to investigate further whether similar bias exists in multilingual models and other AI algorithms. Thank you for your attention, and if you're watching this video and have any questions, please feel free to reach out to us by email. Thank you.